Hello, Geometry. This is the last section of Chapter 3. This is Lesson 5. Been dealing with parallel and perpendicular lines. We're going to put those parallel and perpendicular lines on the coordinate plane and deal with some equations. So this is going to feel like algebra class. So if you enjoyed algebra class, we're going back to that today. And if you didn't, then we get a little bit of review here. So parallel and perpendicular lines, and dealing with the slopes of them and y-intercepts and slope-intercept form, and all that is happening right now in this class. So here we go. Question is, how can you write an equation of a line that is parallel or perpendicular to a given line and passes through a given point? So we want to remember slope-intercept form is y equals mx plus b. M represents the rate of change or the slope that you're having. B is your y-intercept or your starting point if you're dealing with an actual situation. Okay, so M is a slope, B is the y-intercept. We could use point-slope form. Point-slope form, that was y minus y1 equals M times x minus x1. Okay, and that's when you're given a point, x1, y1, and a slope, m. So when you have a point and slope form, that's why you call it point-slope form. So notice that's what it's talking about here, given a line, which means we have a slope, and passes through a given point. The final one, you won't see too much, is called standard form, but it's not too standard, ax plus by equals c. If you want the shortcuts for finding slope here, your slope is going to be the opposite of whatever a over b is. A is always in front of the x, the coefficient of x. B is the coefficient of y. The opposite of a over b would give you your slope. Your y-intercept would be c over b, big B. So little b would be c over big B. Okay, so let's review a little bit here on page 86 with these formulas. So they say write an equation of the line that is parallel or perpendicular to the given line and passes through the given point. Use a graphing calculator to verify your answer. So you notice here we have they want two parallel lines. Okay, this one goes through 0, 2. We need to remember that parallel lines, they are going to have the same slope. Parallel lines have the same slope. So this equation right here is in slope-intercept form. Y equals mx plus b. So plus b would be a -1 in this case. This is our m. This is what's important. There's our slope right there. So if we want an equation through this point, this is going to be x1, y1. So we have x1, y1, and we have an m. We're using point-slope form because we have a point with a slope. So I'd go y minus the y value, so y minus 2 equals m. M is 3/2 times x, that first x stays an x, minus my x value, which is 0. We would distribute normally, but we have a 0 there, so y minus 2 equals 3/2 x, then minus whatever that would be if we had to distribute. Then we'll add the 2 over. Our final answer would be y equals 3/2 x plus 2. There's your equation for that second line. Okay, so we go on here. They want these to be perpendicular. We want a perpendicular segment right there, perpendicular angle. So this is still 3/2. Now the rule for perpendicular slopes is they have to be what they call negative reciprocals. Negative reciprocals. So negative means opposite. I usually say opposite, but the textbook uses the word negative reciprocals. So if this is my slope here, we are going to use an m that is the opposite of 3/2, or the negative of it. So that'd be negative and reciprocal. So 3 over 2, this is going to be 2 over 3. So when you want perpendicular lines, you use slopes that are negative reciprocals or opposite reciprocals. Okay, so now we do the same thing. We're going to go y minus 1 in this case, because here's your x1, y1. Y minus 1 equals -2/3 times x minus 0. So y minus 1 equals -2/3, there we go, x. Add the 1 over, you get y equals -2/3 x plus 1. That'd be the equation through here. Okay, you can go to Desmos and kind of graph these and make sure they look perpendicular. Okay, C, parallel or perpendicular. Okay, they're parallel. That means we're going to use the same slope. We're going to use the same slope there. So again, y minus y1. So here's x1, here's y1. So y minus y1. So y minus a negative 2. So that's going to be y plus 2. Minus the negative, y plus. Equals m, we're using 1/2 times x minus 2 times x minus 2. So y plus 2 equals 1/2 x minus 1. 1/2 x minus 1. Then we minus 2 from both sides, and we're going to get y equals 1/2 x minus 3. 1/2 x minus 3. There's that equation. Perpendicular. What is the negative reciprocal of 1/2? Well, it's positive, so we're going to have to use negative. Reciprocal of 1 over 2 is 2 over 1. Just flip the fraction around. So we're going to use negative 2 for our slope. So y minus, what's my y value I want to go through? I want to hit this target right here. So that's going to be y plus 3, because it's y minus a minus 3, equals negative 2 times x minus 2. Distribute the negative 2. Y plus 3 equals negative 2x plus 4. Then minus the 3 over. So y equals negative 2x plus 1. I minus the 3 from the 4. Okay, try E and F on your own. Come back, I'll give you the answers. We're looking at parallel lines. Notice here, I want you to notice back up here, 0, 2, that's a y-intercept. Notice what your y-intercept was. There's a little shortcut there. 0, 1 was your y-intercept. Look what your y-intercept was. Okay, so if they're giving you the y-intercept, that's going to be the b value. So a shortcut here is we know we have to use m equals negative 2. We want this parallel. So we could go y equals negative 2x minus 2 because that's the y-intercept. That only works if the x is 0. So you can only use the y value for the y-intercept if x equals 0. That's the definition of an y-intercept, is when x is equal to 0. So if I look at this one, can I use 4 as my y-intercept? Because there's a 0 there. The answer is no, because that's an x-intercept, not a y-intercept. So we went perpendicular. This is negative 2. What's the negative reciprocal of negative 2? Well, the negative of a negative is a positive. The reciprocal of 2 would be 1/2. So I'd go y minus my y value, y minus 0 in this case, so it's just y, equals 1/2 of x minus 4. So we get y equals 1/2 x minus 2 once you distribute. Okay, so there's some algebra review with working on those equations. I'll show up here in a little bit. Page 87, we kind of practiced that already. We won't do anything more with that. Okay, what we have now, something called a directed line segment. Okay, a directed line segment. That is when they give you a line that represents the motion from one place to the next, and we're going to practice this before we get on to these new theorems here, which we already know pretty much. A directed line segment is represents moving from point A on a segment to point B. Moving from point A on a segment to point B. Okay, that sounds really fancy, doesn't it? So what the questions ask is this right here. These are the directed line segment questions. Find the coordinates of point P along the directed line segment AB so that AP to BP is the given ratio. What? Okay, AP to BP is the given ratio. So we have 2 points here. This is where we want to use graph paper. I got A at negative 2, 7. 6, 7. So there's A, negative 2, 7. And B is at negative 4, 1. 2, 3, 4, 1. So negative 4, 1. So we have a segment here. And they want a ratio of 3 to 1. So they want a point. So they want a point on AB, segment AB, that splits this segment into a ratio of 3 to 1. So into a ratio of 3 to 1. So what we do here, if the ratio is 3 to 1, sorry, did you not see that? There we go. We want what? Did I put what? We want a point on AB that splits the segment into a ratio of 3 to 1. Okay? So that point is 3 over 3 plus 1, or 3/4 of the way from A to B. 3/4 of the way from A to B. Okay, keep in mind this right here came from adding the two numbers that were right there. Okay, so this is the top number. So it's the first number over the sum of the two parts. The first number over the sum of two parts. So if you had a ratio, let's just say you had a ratio of 5 to 2. Ratio of 5 to 2. That means it's going to be 5 over 5 plus 2, or 5/7 of the way. Okay? If you remember probability and odds a little bit, kind of goes back to some of those things. If you had a ratio of 1 to 5, that means it's going to be 1/6 of the way along the line. Okay. So the next step is to find the rise and run. Okay, find the rise and run. So we go back to here, and this is where I think it's very helpful to do it on a graph. Okay, so we have 1, 2, 3, 4, 5, 6. So we have a rise of 6, and we have a run of 2. So find the rise and the run. So the rise equals 6, the run equals 2. Okay, now keep in mind we're going down. We're starting here. We're going to start at A. Make sure you start at A. We're going from A to B. So we're actually going down 6 and left 2. So I'm going to put the rise as negative 6 and the run as negative 2. Negative over negative does make a positive slope. Okay. Multiply rise and run by 3/4. So the 3/4 came from up here. This is the next step. That 3/4, I'm bringing it down. I'm going to take negative 6 times 3/4. I'm going to take negative 2 times 3/4. So negative 6 times 3/4, that'd be negative 18/4, which is negative 4.5. This would be negative 6/4, which is negative 1.5. Okay, we're almost there. Add the rise value to the, rise is a y value of A. Has to be of A. So those 7 plus negative 4.5 would equal negative 2.5. That's a y. So y is 7 plus negative 4.5. So 7 from the y value plus negative 4.5 is negative 2.5. Add the run to the x value of x value of a. So our x, our x value is negative 2, is negative 2 plus negative 1.5, and you get negative 3.5. So our point is going to be at negative 3.5. That should be positive. Sorry, the y value. 7 plus negative 4.5 should be positive 2.5. Negative 3.5, 2.5. So if we go negatives back here, 1, 2, 3.5, 1, 2.5, right there. That should be our point P. That is 3/4 of the way from A to B. Okay, that means you have 3 segments over here for this one segment here. This one segment should fit 3 times up there. Whew. How about those steps? All right. Let's do another one. We want another one, just like the other one. Okay. Tell it's time for me to go home. Number 2. A is 3, 1. B is 8, negative 2. The ratio is 2 to 3. So a ratio of 2 to 3, that means we need to be 2 over 2 plus 3 is 5. 2/5 of the way from A to B. In that direction. It has to be that direction. Start working with vectors and physics and stuff like that, you're going to be using this a little bit more. So again, I'm going to plot this out. A is 3, 1. 1, 2, 3, 1. You can do all this just with the numbers. I think the graph is helpful. B is 8, negative 2. So A is 3, 1. 4, 5, 6, 7, 8, 1, 2. B is 8, negative 2. So you want to be along that line by a ratio of 2/5. So I look at my rise and my run. Again, you can use the slope formula for that, but here's my triangle. And there's 1, 2, 3, so that's down 3, so I'm using negative. So start at A. Remember to start at A. So I'm going down is negative, I'm going to the right. 1, 2, 3, 4, 5. Okay, I'm going to the right 5, so that's positive. So if you're going up or right, it's positive. If you're going down or left, you're going to be using negative numbers. Okay, so we're going to take negative 3 times, green. Can you watch green? Negative 3 times our ratio, there's a new one here, which remember was 2/5. 2/5 right there. So it's negative 3 times 2/5, that would be negative 6/5, which is negative 1.2. That was on a rise, so I'm going to add that to my y value. So 1 plus negative 1.2, we get negative 0.2. There we go. So you take your y value plus that answer right there. For a point P, I don't like how that looks. We know the y value is going to be negative 0.2. So now we go do it with the x value. We have 5 times 2/5. That's just going to be 2. So we take our x value of our point, 3 plus 2, and that gives us 5. So that should be 5, negative 0.2. So 1, 2, 3, 4, 5, right there. That should be our p value. That's 2/5 of the way from A to B. Ratio of 2 to 3. 2 of these segments and 3 of those segments would all be congruent. All right, good job. So number 2, the point was 5, negative 0.2. Number 1, the point P was negative 3.5, 2.5. Okay, determine which of the lines are parallel and which of the lines are perpendicular. Let's go back to that. Okay, so back on page 88, slopes of parallel lines in a coordinate plane. 2 non-vertical lines are parallel if and only if they have the same slope. So equal slopes. Remember your slope formula is y2 minus y1 over x2 minus x1. So when they give you 2 points, let's say we have 2, 4, and negative 8, 3, you can label them as x1, y1, x2, y2. And then plug each of these points into your formula. You're subtracting your y's, so m equals 3, y2, minus 4, over, now always go back to the point you started with. Now, these points could be written in a different order, and it doesn't matter. You're going to end up with the same answer. So it should be negative 3, 8, minus 2. So we get negative 1 over negative 10. So this slope would be 1/10 between those 2 points. Okay, in the coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. Okay, that's going to be a question on the assignment. The product of their slopes are negative 1. That means they are negative reciprocals. So if you have a slope of 3, the perpendicular slope, so if m equals 3, your perpendicular slope would be negative 1/3. If m was 2/5, your perpendicular slope would be the negative reciprocal, so negative 5/2. If m was negative 8, your perpendicular slope would be positive 1/8. Okay, so m1 times m2 would be negative 1 if you multiplied these two together. Horizontal lines and perpendicular lines are perpendicular. Remember, horizontal lines would be something like y equals 3. That's a horizontal line. Vertical lines would be something like x equals 2. So vertical lines have x equals. They have an x-intercept but no y-intercept. Horizontal lines have y-intercepts but no x-intercepts. Yay, Algebra 1 is back! Okay, so determine which of the lines are parallel, which are perpendicular. So it looks like P and Q. Let's check that. So we have these 2 points. You can pick several points here. So between here, where I'm going up 1, 2, 3, 4, 5. I'm just going to go off the diagram here, and I'm going over 1, 2, 3, 4, 5. So this slope is 5, 6. This slope is 1, 2, 3, and 1, 2, 3. Ooh, not quite. Did I do that right? -4. Where does that? Oh, that goes down there. Okay, 3, -1. There we go. Yes, 1, 2, 3. So this line, this has a slope of 1. So those two are not parallel. I'm just using rise over run with this. You can also use your formula. So make sure you find the right points. You see how that arrow is pointing to that one right there? That kind of tripped me up. So down here we have a 1, 2, 3, and 1, 2, 3, 4. So this line right here, your slope is negative 3/4. This one here is 1, 2, 3, 1, 2, 3. So that's 3 over negative 3. So that slope should be -1. And finally here we have 1, 2, 3, 1, 2, 3, 4. This is 3 and this is -4. So this slope is rise over run, negative 3/4. Can you tell all those lines? Did I count this right? 1, 2, 3, 4, 5. 2, 3, 4, 5. That's 5/5. Like some of these should be parallel. 5/5, so that is 1. Okay, so you notice these two are the same slopes. So P is parallel to Q. You probably already corrected me on that one. P and Q should be parallel. And then it's going to be T and R have the same slope. So T is parallel to R, same slopes. And then S has a slope of -1. -1 times 1 equals -1. Those are negative reciprocals. So we could say P is perpendicular to S and Q is perpendicular to S. But it all comes back to finding those slopes. You can use rise over run and draw your triangles. You can use a slope formula. m equals y2 minus y1 over x2 minus x1. Next set of questions, tell whether the lines to the given points are parallel, perpendicular, or neither. Justify your answer. So I'll just use my slope formula here. That's x1, y1, x2, y2. So m is y2 minus y1 over x2 minus x1. So you get 2 over negative 4, you get negative 1/2. Okay, so down here, x1, y1, x2, y2. So your m is going to be y2, 4 minus y1, 4 minus a minus 2, that's going to be 4 plus 2, over 4 minus 1, so that's 6 over 3, which is 2. So you notice we have negative 1/2 and we have 2. If I take 2 times negative 1/2, I get negative 1. So when I multiply the slopes, I get negative 1. These are perpendicular lines. We could just say slopes are negative reciprocals. Or you can say the product of the slopes is negative 1. A little bit longer than the last couple lessons, isn't it? Okay, write an equation of a line passing through that point, 3, 2, 3, negative 2, and is parallel to that. Graph the equations of the lines to check that they are parallel. We practiced this earlier. We want to be parallel, so that means the same slope. So we're going to use m as 2/3. So this is x1 and y1. So y minus y1 equals m times x minus x1. We're going to use a point slope formula. So go ahead and pause, plug in your number, see if you can get the right equation. So y minus a minus 2, so y plus 2 equals 2/3 times x minus 3. So y plus 2 equals 2/3 x. 2/3 times 3 is 2. So minus 2, minus the 2 from that, you get y equals 2/3 x minus 4. So graph both of these to make sure they are parallel. So there's my y-axis. Looks like I need to be a little bit lower. So my first line has a y-intercept of negative 1 right there with a slope of 2/3, so that's up 2 over 3. Up 2 over 3. Yay, algebra is back. How many times can I say that? I'm sure you're all excited for it. Here's your first line. Second line has a slope of y-intercept of negative 4. 1, 2, 3, 4. Up 2 over 3. Up 2 over 3. Or you can go down 2, left 3. So if you're not looking parallel, that means either you did your work wrong or you graphed it wrong. Write an equation of the line passing through negative 2, negative 2. That is perpendicular. So if this slope is 2, our perpendicular slope is going to be negative 1/2. So we use the same formula to set it up. Y minus y1, so y minus 2, equals negative 1/2 times x minus a minus 2, so x plus 2. So y minus 2 equals negative 1/2 x minus 1. That's a negative 1/2 times a positive 2. That'd be minus 1. Add the 2 over, you get y equals 1, negative 1/2 x plus 1. Okay, so our y-intercepts are 1 and 3. So I can make my x-axis a little bit lower here to give me more room at the top. So y-intercept of 3, 1, 2, 3. And then up 2 over 1, down 2 left 1. Okay, again, these should be looking perpendicular. Yeah, let's do green. So y-intercept of 1, and then down 1 over 2. 2. Or up 1, left 2. Just put x's so you can see it easier. Okay, that does look perpendicular. We did it right. Find the distance. Before we go on there, keep in mind, if they give you equations like 2x minus 4y equals 9, if you're in standard form, your slope is going to be the opposite of 2 over negative 4, the opposite of A over B. You can also solve for y if you remember doing that. So this slope is positive 1/2. This slope is positive 1/2. Okay, if you want to make that equal to y, you could say negative 4y equals negative 2x plus 9, then divide everything by negative 4. Get y equals 1/2, negative 2 over negative 4, 1/2 x minus 9/4. Okay, but your slope is 1/2 there. So you might have you'll have some in standard form. Do the opposite of the x value over the y value. So negative 2 over negative 4 is 1/2. That's that slope. So your perpendicular slope there would be negative 2 if you needed that. The other thing is, remember, if you have a vertical line, you'd have something like x equals 6. So if you want a perpendicular one, perpendicular to x equals 6 could be y equals 4. Okay, so x's and y's, those are your vertical and horizontal lines. Okay, that goes back to this statement here, how we said y equals 3 and x equals 2. So if you have a specific point, let's say here, you want this point. If you want a horizontal line, sorry, there we go. You have this point. If you want a horizontal line, you could say y equals 2. That's the equation of horizontal line. It's a horizontal right through here. If you want something perpendicular to it, you would say x equals negative 2. So you notice those two lines are perpendicular to each other, and they both go through that point negative 2, 2. Same with that green one. Okay, find the distance from point A, 0, 5, to y equals negative 3x minus 5. Stems from what we did before. We're going to use graph paper for this again. A is 0, 5, so A is 1, 2, 3, 4, 5. Here's A. I'm going to graph this line, being as precise as I can. So negative 3x minus 5, so 1, 2, 3, 4, 5. There's negative 5, a slope of negative 3. I'm going up 3 over 1. Over 1. Okay. That's pretty good. There's my line. So we want the shortest distance from this. Okay? So since this slope is negative 3, remember the shortest distance is going to be perpendicular to that line. Okay? So the shortest distance is perpendicular to the line. So use m equals 1/3 perpendicular slope. So use the perpendicular slope from A. Use m equals 1/3 from A. Why am I going green there? Okay, from A. So I'm going to go back to my point. I'm going down 1 over 3. Notice how it meets up right there. Down 1 over 3. So we want to find this distance right here. We want to know that. So we can use Pythagorean theorem. There's 1, there's 3, 1 and 3. Distance is going to be the square root of 1 squared plus 3 squared. That's the square root of 1 plus 9. It's going to be the square root of 10. Square root of 10 is about 3.12. Sorry, 3.16. So about 3.16 units if they want to the hundredth. If you want less, oh, there we go. Okay, so that's how you do it. Again, come back and watch this if you need it. Distance from a point. Find the slope of this line. Use the perpendicular slope from the point they give you and to draw that line, and then find the length of that line. Okay? So we can make up an equation. Let's say we have y equals, go blue birds, y equals 2/3 x minus 4, and the point is negative 3, 5. So we want the distance from this point to this line. So I'm going to draw that line, 2, 3, 4, up 2 over 3, 2 over 3, 2 over 3. So I'm drawing the line first. So we draw that. We want to place that. So negative 3, 5. 3, 1, 2, 3, 4, 5. I don't know how this is going to work. Let's call that point A. So we're going to start at A. Use the perpendicular slope towards the line. So the perpendicular slope here is going to be negative 3 over 2. Negative 3 over 2. So I'm going to start here. I'm going to go down 3, 1, 2, 3 over 2. Down 3, 2, 3 over 2. Okay, so this isn't going to match up. You won't have any that don't really match up like this. I hope not. If they do, let me know. So we would want to find, we'd have to find this point, which requires a system of linear equations. We'd have to find the equation of this line and then find out where that point is. That's going to be some random place in there. Okay, so we're going to be done with it, but you would need this. All of your examples should match up perfectly to a point right here. We're not quite that in depth yet with this. To find that if it's not on an exact point here. But you can do a system of equations with these two equations, find out where that intersects, then you have this point, and you find the distance between those. So, I think this length of this one makes up for the short ones that you've just got done. Hopefully you're still with me, you watched till the end. That will help you in the assignment, and I'll see you soon. Good work.